Hello, calculus fans. Let's try to evaluate the integral from 0 to 7 root 3 of square root of 49 plus x squared dx. This calls for an inverse trig substitution, the type that's an arctangent because we're adding two things inside the radicand. So we're going to let theta be equal to arctangent of x over 7. So how do we come about this? Well, the 7 was because 7 squared is 49. So anytime you see square root of a squared plus x squared, you're going to make an inverse tangent substitution. So we got tangent theta is equal to x over 7. As usual, we'll draw the triangle. Oh, we also have to change limits of integration. Theta of 0 is arctangent of 0. That's just 0. Theta of 7 root 3 is arctangent of 7 root 3 over 7. That's arctangent of root 3. This is another one of these that we should be able to work out. That's pi over 3, because tangent of pi over 3 is root 3. All right, now we'll do the triangle. Okay, so if tangent of theta is x over 7, that gives us these two sides, and as usual, the Pythagorean theorem gives us the remaining side. Make sure you work all that out. We also know that secant theta is equal to square root of 49 plus x squared over 7. We're writing this down because we need to solve for square root of 49 plus x squared. Okay, here we go. If we multiply both sides by 7, then we'll get this. Let's see, what else do we need? Well, we also need a dx. So remember that 7 tangent theta was equal to x. So if we take a derivative, we'll get 7 secant squared theta d theta is equal to dx. Okay, that's all the pieces we need. Now we can transform the integral. So if we take our original integral, we rewrite it. Keep in mind we've got new limits of integration. They're going to go from 0 to pi over 3. We want new limits of integration so we don't have to go back to the original variable. The square root of 49 plus x squared turns into 7 secant theta. The dx turns into 7 secant squared theta d theta. All right, so the 7 times 7 turns into 49, and then we have secant cubed theta d theta. Now this is an example of the thing that we talked about earlier, that it's actually worthwhile knowing an antiderivative of secant cubed theta. Remember that when we did this, we had to do recycling. This is not something I want to have to repeat, so I think it's actually worthwhile committing an antiderivative of secant cubed theta to memory. So if you remember, it was 1/2 secant theta tangent theta plus 1/2 log of the absolute value of secant theta plus tangent theta. Of course, we still have the 49 lurking out in front. Now we'll plug everything in. We'll plug in the pi over 3 and the 0. Now if you work these out, this is going to be 0, and log of this thing is also going to be 0. That's because secant of 0 is 1 and tangent of 0 is 0, so we end up with log of 1 and that disappears. So that's nice. When we plug in the 0, everything just disappears. All of this is gone. Gone. And so we're just left with what's with the pi over 3, and if we work all out, then we get something that looks like this. Because secant of pi over 3 is 2, tangent of pi over 3 is root 3. So this is actually going to be our final answer. Okay, that's all for now.